Okay, number two, this is the quiz. This is the confidence interval question. And regression analysis on the relationship between average annual profits in millions of dollars and insurance companies and the yearly number of major natural disasters, hurricanes, tornadoes, and earthquakes gives the following computer output. So we know we're looking at annual profits and number of major disasters. So those are our X and Y, but we don't really know which one is it when I read this scenario. And that's unfortunate because the very first thing that the recipe says is we need to define X and Y, and yet we don't know which they are. But the computer printout gives this to us. Remember, this row refers to our Y-intercept. It may say Y-intercept, it may not. And so this is our intercept, and this is going to be my slope row. And whatever they have there gives us a clue to our X. So this tells us our X is going to be natural disasters. So let X equal the number of disasters. Awesome. And that means let Y equal the annual profit in dollars. And yes, I know we did this on the previous example, but I want you to do it twice. So when you submit your work, make sure you've done this twice as well. The next thing we need to do is we need to find beta 1 in context. So this was number 1. Number 2 is defining beta 1. And in this particular instance, we can say beta 1, let beta 1 equal the amount of change in profits for every 1 unit change in the number of natural disasters. Okay. The next thing it asks for is write the conditions. Well, in our case, we're lucky our conditions are satisfied. We don't have to mess with that. So we're just going to say conditions satisfied. And really, I should say satisfied. I should say that's just a given. I think I did that on a previous video, but I should have done that. All right, so from there, we need to move along and write the formula for the test. Our formula is very easy, and it's going to be B plus or minus. So my slope plus or minus T star SB. Well, I'm going to start filling in what I know. All right. So the very first thing I know is I know that this is my slope. So I have negative 2.70909 plus or minus. I don't know T star. I don't know T star. So I'm going to leave a blank for T star. We'll come back to get that. So this is my slope. I got that from right here. But I do know SB, which is 0.9694. So now I need to calculate T star. And T star, remember, is going to be inverse T. So second vars, inverse T, parenthesis 1 minus 0.98 divided by 2. And if you notice, when you read the scenario, they did not give us a sample size. But I know my degrees of freedom are given by this residual. So this gives me my degrees of freedom. And if they'd asked me for my sample size, which I think that would be a fair question on multiple choice, it would be degrees of the sample size, N equals degrees of freedom plus 2. So N equals 9 plus 2. And remember, degrees of freedom just happens to be n minus 2 for residuals, all right? So in this case, we know we have a degrees of freedom of 9 because we had a sample size of 11. And I end up, let me check that one last time. Second vars, because I hate to do my work with it being wrong. That looks good. So I end up getting a T star of 2.82. I'm just going to keep it short at 2.82. All right, so there's not an easy way through the calculator to do this, so I'm going to go ahead and have to calculate this by hand. So I'm going to do the negative first. So I start off with negative 2.70909 minus 2.82 times 0.9694. And I get a value of negative 5.44. So that's my lower bound. And I can go back and do the upper bound. And I'm going to do that the same way, negative 2.70909 plus 2.82 times 0.9694. And I end up getting a positive 0.0246. Now this is something that we should take note of. This is my upper bound. I'm going to go ahead and point this out now. We went from negative to positive, and I'm probably going to label that. So if I go from negative to positive, 0 is contained. I do not have to make that statement, but that might help you out. That just may help you out when you're actually making decisions about that. So it does not ask us to define the confidence level. It doesn't need us to ask us to do that, but we always have to give a conclusion. So our conclusion is we are 98% confident that the true population slope for annual profits relative to number of natural disasters lies within the interval negative 5.44 to 0.0246. All right. So here's the thing. That's correct. And what did we actually learn from that? We actually learned that because 0 is contained, our slope is not significant. And part B, zero is contained in the interval so our slope is not statistically significant. This aligns with the hypothesis test at alpha equal 0.02. Because that's what we ran. It's a hypothesis test at alpha equal 0.02. And why is this? Well, why do they completely line up? Well, the hypothesis test was alpha equals 0.02, which is the area in the tails. So the area in our tail was 0.01 and 0.01, which means 98% lies in between, which is exactly the same as our confidence interval. And our lower bound, of course, is the negative 5.44 to a positive 0.246. Barely crosses over 0, but it does. All right. So it barely crosses over, but 0 is contained in the interval, so our slope is not statistically significant. This is the same as what we got at our hypothesis test at alpha equals 0. This occurred because both are two-tailed tests with the same area in the tail. Because both have an alpha, which is the area in the tail, equal to 0.02, and were two-tailed test. Because remember, sometimes a one-tailed test and a one-tailed test would not be the same as it compared to a confidence interval. A one-tailed test has all the area in one tail. So 0.02 would have been one or the two tails. When there are two-tailed tests, when we have the HA being not equal, we have the area divided between the two tails. All right, thank you. And we'll move on to the next video.